Decoding Starlight, we're going to look at the velocity of stars. And velocity is speed in a particular direction. And how do we determine the velocity of stars? We're going to use their spectra, and we're going to see how their spectrum would be shifted according to whether it's moving towards us or away from us. So the center band with the absorption lines in it is stationary. So that object appears not to be moving. But if an object is moving away from us, the top line, those dark lines have been shifted to the right towards the red end to show that that star would be moving away from us. And the bottom line, compared to the middle one, the lines are shifted towards the blue end, showing that the star would be moving towards us. And the greater the shift, the faster a star is moving. Due to the Doppler effect, similar to when you hear a noise of an ambulance siren coming towards you and passing, the frequency changes, and the Doppler shift is happening here. We're also going to look at the mass of stars. We're going to start off with actually looking at objects which may or may not be considered true stars, brown dwarfs. And the visible light image of part of the Orion Nebula doesn't show many of them. The infrared image shows the smaller lights there are brown dwarfs, and they're between 30 and 80 times the mass of Jupiter. So, if you like, big planet size rather than star size. And the smallest mass a true star can have is about a 12th that of the Sun, and the true star fusing protons to form helium, and that's what's happening in the inner core of our Sun. And between 100th and a 12th might produce some energy, but not enough to fuse protons, and they're given the name brown dwarfs. And if we're looking at mass of stars compared to their luminosity, we have the mass-luminosity relationship, and the luminosity L squiggle is directly proportional to the mass to the 3.9, so about to the 4th power. And so if you compare two of them, a luminosity known, an unknown mass, we know the luminosity of the Sun, we know the mass of the Sun, you can put the L over L Sun equals M over M Sun to the 4th power. And so you can then rearrange that to calculate the mass of a particular star. And then binary stars, some more formulas here. So some to the naked eye, like Sirius, the brightest star in the sky, is actually a binary star, but the Sirius B is tiny, and you can get the distance between the star centers, and you can calculate their masses as, or the mass of the secondary binary star from the equations that are given. And there's an animation that you can go to, and you can check out that QR code to see the animation. And to find out a little bit more about decoding Starlight, if you haven't already, what are stars? What makes up a star? What is it made of with stellar spectra? And be an astronomer for an evening or more, and what you need to know to view the night's sky. Enjoy stargazing.